Hey everybody, this is Larry. This is day 21 of the Leetcode daily challenge. So if you found this video and you want to understand the problem a little bit, check out the link somewhere, and I go over the problem a little bit. So the purpose of this particular video is to kind of go over another solution that we already have. That to kind of go over, I kind of gave a hint about it the last time. So the solution that we had was a binary search, where this is O of log of n times log m, and it's good enough, it's fast enough. But the question is, can you do better? And so I gave a hint about an O of m times n. Oh, sorry. I gave a hint for an algorithm that's O of m plus n. And I got a lot of requests about this kind of describing that problem. So let's kind of go over that real quick. Yeah, so let's say you have a test case. Okay, well, so the algorithm let's talk about the algorithm first, and then I'll code it up, and then we can leave your comments below. But basically, the idea is that you have some matrix. This is, and it has some order, which you can kind of encode it in a way of sorts. So something like that, say, right? Okay, maybe that's a bad example. Let me rewrite this a little bit. So the algorithm that we had on the other video, which you should watch it first. It's a little bit of prerequisite. If not, then maybe some stuff may be a little bit confusing. But basically, what we do is we binary search and we just get the index for each one, which is fine. O of n times log m, right? So can you do this better? Can you do this in linear time? And some may argue that log m is almost effectively linear, given that m is less than 100, and and log 100 is not that big, right? It's like 8 or so. So it's effectively constant, and it scales pretty well. But if you wanted to challenge yourself, well, see if you can figure out the linear time solution. And the way that you would come about is actually just start at the upper right corner and then ask to see if it's a 1. If it's a 1, then go move to the left. Move to the left, move to the left, move to the left. And then now you say that this is 0. Well, that's no good, right? So then that means now from this 1, we go down to here. So 0. Well, what is this 0 now? Well, okay, let's go back a little bit. So the first one, we know that then by going to the left 5 times, that there are 5 ones, right? So now that you go down from here, what does that mean when you see a 0? If you see a 0, that means, well, our current max, or our current leftmost column, it's already better than this column. So we don't even have to look at this row, right? Because this row, whatever it is, because it's 0, it's smaller than our current best, right? So then now from here, we go down and we see a 1. So then it may beat us. So then let's go to the left. And then it may beat us. So let's go to, or it already beat us. So then now it goes to left, it's 0. So then now from this leftmost 1, you go down again. And then and then so forth, and it goes all the way down. So that's the algorithm. So the question is, well, what's the complexity for this algorithm? Well, the complexity is O of n times m, because at most you're going to go O of n times to the O of m times to the left, and O of n times down, right? And each of them costs 1 query. So there you go. That's your O of m plus n algorithm. Yeah, it's kind of a clever thing that comes up from time to time, but it's a little bit more of a trick than something that you would use that much. But it's still nice to know, I think. And did you figure it out? Let me know. And that's the explanation part of it. Now, if you'd like, you could watch me try to code it up in real time. So there's no edits, or maybe it's a little bit slow. If so, then watch it in 2x or whatever. You could also take this time, of course, to hit the like button, subscribe button, leave a comment. Did you find this linear time algorithm? Was it better for you? Let me know. Okay, so now let's start at the upper right, the top right, right? So current x is equal to so what's the top right, right? So top would be 0 for x, or current. Let's just do current row, so that's clear. Current column is equal to all the way to the right, which is m minus 1, right? So now Yeah, so now while current row is less than n, because once we processed all the row, we know we're done. And you can actually maybe do this in a for loop actually. Uh, but I like to think in while loops a little bit, with, at least for stuff like this where you're like doing major changes, but that doesn't really matter, I think. Okay, so while this is true, okay, let's query. So the query is binary matrix dot get current row, current column, right? And then let's just have a best variable. I call it best, which is leftmost. Let's call it leftmost then. Leftmost is equal to, let's start with m. Um, yeah, because wherever you go, it's going to be a little bit better. Yeah, and then if this is equal to 0, is it number 0? Just want to make sure. If this is equal to, if this is equal to 1, then we can move to the left, right? So let's just actually do while this is true, let's move to the left. And current column is equal, or it's greater than 0. Or greater than or equal to 0. And yeah, and then it goes all the way to the left. And then now you're at the condition where the current column is 0 or it is less than 0. So let's check both those cases. You could do this in a number of ways, but I'm going to just try to be more explicit. So if the current column is less than 0, then that means we can actually return 0 because you're not going to do better than that, right? So you can actually return early. If the other case is, yeah, so if it's not all the way to the left, then you actually want to move the current columns plus 1, right? Because if you kind of illustrate this, we was like, okay, we're here. This is 0, so now let's go down, right? So now current column. But so that's kind of my first intuition. And of course, at the end, current row plus 1, and then you can just do leftmost. And also, of course, but let's put down the cases. I don't think I'm confident about this, and also I didn't check, but that's fine. Leftmost is equal to min of current leftmost. I think that's after it gets to plus 1. And also you have to check that if leftmost is equal to m, then we turn -1 because you've got nothing. But I think I'm doing a little bit of checking and conflating at the same time. So let's kind of check that. Let's just do if binary matrix dot get current row, current column is equal to 1, then we start this. So then we could just do yeah. Because then now we can see that if it's 0, then we just go directly to the next row with the same current column, and we don't have to worry about these edge cases. But yeah, but now let's already do the offset. Let's just do offset is equal to -1. So then we now don't have to worry about this thing. And then now let's say if current column plus offset is, yeah, it's greater than 0, and this is plus, then we can do offset gets a little bit smaller to the left, and otherwise, yeah, and then we could just set current column is equal to current column plus offset -1. Oh, sorry, plus 1. Because we want to go to the first one that's to the right of the zeros. I think that could be it. Let's test all the cases again. Yeah, I missed one. Okay. And also test the, yeah. Oh, have a typo on return. How did that R get so far away? Or the T get so far away? That was just a really bad typo. And now I didn't finish writing this, so it's going to give me an issue. Cool. Yeah, so we definitely did not care about the -1 case. Um, yeah, because we start our current column at n-1, so this is always going to give you, at worst, current column is n-1. But actually, in this case, we could, yeah, that is an edge case that I have to think about a little bit. Yeah, I guess we would actually only put this if one of the columns is has at least one in it. So so actually we could just do that, and that's great. Now let's try. Let's do a few more cases, or have some cases where the answer is not order, right? And this one will be more diagonally. Now let's just do it this way. So because all the answers are like 0, 1, and -1. So let's hopefully get an answer that's 2. And maybe just one more. Okay, whatever. Let's submit. I think that's off by 1 is tricky, but yeah. And there you go. So that is the second way to do it. Let me know what you think. Let me know if this video is helpful because I already recorded a video. And yeah, let me know if that's something that you're interested in. And thanks for watching this again for the second time. It is kind of interesting, and it is an algorithm that comes up in a couple of places in some sort of way where you have to walk the grid, and it's kind of cute. So let me know what you think. All right, bye-bye.